And we have an equality statement from which we can build a conversion unit. In my class, you're required to have the equality statement to justify the conversion unit. Okay? You find the side of the equality statement whose units and species match the starting amount up here. In this case, we've canceled everything but this, so we want to match these units and species here with this the side of the equality statement down here and put that on the bottom. So we're going to put 1 mole of calcium nitrate on the bottom. That's this side of the equality statement. And put the other side of the equality statement on the top. 164.088 grams of calcium nitrate. Cancel as we go. Okay. And now we're ready to calculate an answer. All right. I earlier gave you a quick way to use your calculator to do this. I want to remind you of that. You're going to take each thing across the top and multiply it. And of course, multiply by 1 is the same number, so you could just ignore that. Okay? So we got 5 times 3 times 164.088. 5 times 3 times 164.88, 088, and hit enter. Then you're going to hit your divide key and divide. You don't have to divide by 1s because dividing by 1 gives you the same answer. Any non-1 answer or non-1 part there, 399.878, you can divide by that, 399.878. And I'm going to start putting my answer down here. I should have left some space in there, I guess. But we get 6.155177,329. Okay. Now your calculator may have one less digit or something on the end. That's okay. You just put down the full answer from your calculator. Put down the units and species that are left. We've canceled everything but this unit and species. If you've done everything right, if you set it up right, every unit and species should cancel except the one that you're looking for. And it did. We're looking for we're looking for the mass in this case. We're looking for a limiting reactant. We want to find first the mass of calcium nitrate. So that's grams of calcium nitrate. All right. Now we only have, let's see, our part of the problem that has the least number of digits is this first part. Remember, when you're figuring out significant digits in multiplication and division, that's what this is, then you don't worry about the counting numbers. This 1, this 3, and this 1 here. You only worry about the measured numbers like this or the calculated numbers like this and this. And this is the one with the least digits. So we're going to round that off to the same number of digits. So 1, 2, 3 digits and start underlining from there. Draw an arrow to show our final rounded answer. And we're going to have 6.16 grams of calcium nitrate. And that's our answer there. Okay? Now, that's the answer we're looking for in this stage. It hasn't given us the answer we're looking for because we're trying to find the limiting reactant. Okay? So, this is what you're going to do. Once you've calculated the mass of the other reactant, doesn't matter which one you start with, but once you calculate the mass of the other reactant, here's the rule you're going to use to figure out what the limiting reactant is. Is everybody ready? Yeah. Okay. If the calculated amount of limiting reactant is greater than a given amount of that same reactant, if the calculated amount, that's this amount right here, is greater than the given amount of that same reactant, okay, then this species is the limiting reactant. This species is the limiting reactant. Okay, so calcium nitrate is the limiting reactant.
Could you say that one more time?
If the calculated amount of a reactant is greater than the given amount of that same reactant, then that species is the limiting reactant. Yes?
I was about to ask, like, why did we have to balance out the equation if we didn't use it, but then I see that we use it.
Yeah, we use it right there.
So you always.
That's why it's called stoichiometry. What?
So you always have to balance the equation.
You always have to balance the equation if you're going from one species to another. Anytime you're going to have to convert between one species and another species, you have to do a balanced equation, because to go from one species to another, you have to have a molar ratio, and that has to come from the balanced equation. Okay? That makes sense? All right. So what does this tell us? Remember our analogy of making cookies? And we wanted to make the most possible cookies. And we got flour and sugar and butter. And we're going to figure out the ratios to get the most cookies possible.
I want you to add chocolate chip.
Okay, fine, whatever. But the point is, so you can put more or less chocolate chips without really affecting the fact that you can make cookies. Okay? All right, listen. So what you're doing by doing the math with the cookie recipe is figuring out, well, what do I have the least of? What do I need? What's going to run out first when I'm making cookies, right? This is what runs out first. So the definition of a limiting reactant is, the definition of a limiting reactant is, or a simple definition of a limiting reactant is, the reactant that runs out first in a chemical reaction. The reactant that runs out first in a chemical reaction. The reactant that runs out first in a chemical reaction.
What was that first part?
A simple definition of a limiting reactant is the reactant that runs out first in a chemical reaction. Okay? Now, runs out first in a chemical reaction. All right. Y'all are just playing with me, aren't you? No, I don't think so. All right. I am and to quote Misha, you're so childish. Did I nail it? Okay. All right. Now listen, here's the importance of this. Once I find out what the limiting reactant is, now I'm prepared to find the amount of product that might be produced. Once I find out what the limiting reactant is, then I'm prepared to find out how much product might be produced. Yes?
If that wasn't greater, would the other products be greater?
Actually, yes. That's the next thing I want to say. Thank you for bringing it up. Okay. What if, now in this case, we had more of this reactant calculated than we were given the problem. So we identified this as the limiting reactant. The converse of that, if the amount we calculate of a reactant is less than the amount given, then this is the excess reactant. Yes?
So we need 3 times as much calcium nitrate as we do for iron sulfate.
Well, remember what we're comparing here is masses. We can't measure moles. We have to measure masses. And the only way to make all this work out is if we go through Moleville to find out what mass is going to be needed.
Okay, question.
Okay, what's your question?
So, say you do all that work and you come up with the answer and it's less than what you
What did I just say? What did I just say? Will you not? Somebody tell him what I just said.
I was just trying. What was your question?
Excessive.
A limiting
limiting, reactant.
Reactant.
The reactant, they're
No,
running.
excessive or excessive, whatever. I think it's EX.
Be quiet. You can stay after school.
And the what?
I'll answer the question.
You need to listen. If the amount you calculate, if the amount of reactant you calculate is less, if the amount of reactant you calculate is less than the amount given to you, then that reactant species is the excess reactant. Which, yes, indeed, means the other reactant is the limiting reactant. Yes?
So, okay, anytime we do like problems like these, we're always converting them to grams, no matter how much.
Well, you could convert them to other things, but right now we're just working with grams. We could use gas volumes, we could use number of particles, but right now we're working with mass because that's the one that's most commonly used in a wet lab.
Because in the beginning, did you just start off with times it by load, and then, like, it was very simple?
Yeah, we started out really simply. We started out with a mole ratio, and then we added on that at this molar mass, and then we put molar mass on the other end of the equation. And now where we can do that, we're actually putting it into practice in something that's practical in terms of actually being able to use it. Okay? All right. So you're either going to have, so long as you have two reactants, you're going to have a limiting reactant and an excess reactant. Yeah. Okay? So the excess reactant then conversely, the excess reactant is the one that's left over after the reaction runs its course. The excess reactant is the reactant that's left over after the reaction has run its course. Okay? Everybody got that? No, I'm not going to say it again because you guys were playing with me a while ago. You can ask somebody near you to repeat it for you.
Get on. Yeah, you tell them.
Come on, Brian. It was your fault.
Yeah, bro. No.
Come on, bro.
No.
All right. All right.
You gotta hear that song.
What's that?
I'm sexy and I know it.
Okay. So let's add then a new step to the problem. Now that we know what our limiting reactant is, we are prepared to calculate the possible amount of product that will be produced. But which product is the easiest to collect? Which product is the easiest one to collect here?
Calcium sulfate.
Why?
It's a 3. It's a solid.
Yeah, there's the practical part. It's a solid. Because we could filter it out and get the solid out of it. Okay? So you think in the big picture now. Okay? This is the minutia, but don't forget the big picture. Okay? What does this mean in a macro sense? I mean, not a micro sense. Yeah, macro versus micro. Okay. All right. So let's add a new question to this. What mass of solid product might be produced? What mass of solid product might be produced? What now? No, you do not. Let me tell you what you're going to do. Now that we know what our limiting reactant is, this species is our limiting reactant. Okay? We have to listen very carefully. I can't tell you how many students make really poor grades on this next test because they're not listening to this part. Really important here. You start with the given amount of limiting reactant. Not the calculated amount,